Let's go over solving linear equations. So let's say that I have the equation 4x plus 7 equals 10, and I want to solve this. What I want to do is isolate my x variable. So to do that, I need to get rid of this 7 and this 4. We're going to start with the 7. And the way that we get rid of that is, notice how we're adding 7 to this left side. So we're going to do the opposite of that. We're going to subtract 7 from both sides. You're allowed to subtract or add or multiply or divide an equation on both sides by the same number, and it keeps the equation balanced. So we're allowed to do this since we're doing it to both sides. You can see that on the left side, 7 minus 7 is 0, and we're just left with 4x. Or you could say, 4x plus 0, or just 4x. And on the right side, it's 3. So now, all I need to do is get rid of this 4. Again, since I'm multiplying 4 times x right now, I'm going to do the opposite operation. So I'm going to divide both sides by 4. And I end up with x equals 3 over 4. Let's look at another one. Let's say I have negative 9x plus 27 equals 0. Again, I'm going to start off by getting rid of this 27. I'm going to do the opposite of adding, so I'm going to subtract it to both sides, minus 27. We can see that on the left side, 27 minus 27 is 0, so I'm just left with negative 9x. And on the right side, I'm left with negative 27. 0 minus 27 is negative 27. Now I can divide both sides by negative 9. Again, I'm doing the opposite operation. Since I'm multiplying x by negative 9 here, I'm going to divide both sides by negative 9. And negative 9 divided by negative 9 is just 1. So on the left side, we're left with 1x equals 3. Negative 27 divided by negative 9 is 3. Now we have negative 3 plus 5a equals 4a minus 10. So this case is a little bit more complicated because we have a variables on both sides, and we have constants on both sides. So what I want to do is I want to move all of my a variables to one side and all of my constant terms to the other side. It doesn't matter which side, but I'm going to move all my a variables to the left side, I think. And to do that, I need to get rid of this guy that's on the right side. So I'm going to subtract both sides by 4a. And on the right side, 4a minus 4a is 0. On the left side, 5a minus 4a is 1a, or just a, right? So you have negative 3 plus 1a equals negative 10. Now we can get this guy to the right side. So we're going to do that by adding 3 to both sides. Notice how we have negative 3, or we're subtracting 3 from the left side. So to undo that, or to reverse that, I'm going to add 3 to both sides. And I'm left with a equals negative 7. So that's my answer. Now let's look at this one. We have 3 times 3x minus 6 equals 4x plus 7. So for this one, we need to start off by distributing this 3 into the parentheses. And then, we can isolate the x by moving all of my x terms to one side and all of the constant terms to the other side. So we start off by distributing. We do 3 times 3x, which is 9x, and 3 times negative 6, which is negative 18. And then on the right side, we still have 4x plus 7. Now I'm going to move all my x terms to the left side and all of my constant terms to the right side. So I'm going to subtract both sides by 4x. And I'm left with 5x minus 18 equals 7. Then I'm going to add 18 to both sides. And I get 5x equals 25. Now I can just divide both sides by 5. And I end up with x equals 5. So that's going to be my answer. There's one more type of equation that I want to go over. It's similar to solving linear equations, but there's a couple small changes, right? So let's say I have ax plus b equals c. and I want to solve for x, right? This is called a literal equation because it has more than one letter term, right? And these letters don't necessarily have to be variables. They could be, or they could be constants. In most cases, I think they are variables though. So basically, a literal equation is an equation where you have, more than one variable and you want to solve for one of those variables, right? And although it looks a little bit confusing, the process is going to be the exact same. So if I want to solve for x, let's start by getting rid of this b term. I'm going to get rid of it in the same way. I'm going to subtract b from both sides. And I end up with ax equals c minus b. Now I want to get rid of this a. So I divide both sides by a. And just like how, 7 divided by 7 is 1, a divided by a is still 1, right? So I'm left with x equals c minus b over a. Let's say that I had this one. Volume equals length times width times height. And I wanted to solve for width, right? Well, notice how I'm multiplying width by length and height. So I'm just going to divide both sides by length and height. And you can see that they cancel out on the top and bottom. But I also have to divide the left side by length and height, right? So I'm just left with W equals V over LH. I could also have this one. Let's say A equals P times 1 plus RT. So let's say that I wanted to solve this one for R. One thing you might be tempted to do is to distribute this P into the parentheses, but honestly, I don't think that's a good idea here. It would be much simpler for us if we just divide both sides by P, because what happens is we get rid of the P entirely, and we're left with A over P equals 1 plus RT. So now we've sort of gotten rid of that distributing situation, and we just have a much more simple situation here, right? Now I'm going to start off by subtracting both sides by 1, and I get A over P equals, A over P minus 1, right? Because I'm subtracting both sides by 1. A over P minus 1 equals RT. And lastly, I can divide both sides by T, and I get A over P minus 1 all over T equals R. And, there are ways that you could simplify this, but we'll leave it like that for now.